Great, our player now rotates and moves properly. But while we are doing that, we're not really using any of our actual states. We are doing all of this while on the idling state, which of course shouldn't be happening, as idling means standing still doing nothing at all. To fix this problem, let's go to our idling state script. We have a few things to do here. The first thing is to set the speed modifier to 0f when we enter this state, so to not allow our player to move. We can do that by overriding the enter method, and set the speed modifier to 0f. We don't need to set this variable back to 1/2 when exiting, as every state will update this variable to a specific value. The second thing we need to do is to reset our player velocity. This is because we can come from a state that's still moving. If we did not reset the velocity, our player will continue to slide due to physics. We'll be creating a reusable method for this, so add back to the player movement state script. And in the reusable methods region, create a new protected method named resetVelocity. Here type in statemachine.player.rigidBody.velocity equals to vector3.0. As I've previously explained, we'll be setting this to the velocity variable to make sure it is an instantaneous change. Back to our idling state, we now call in resetVelocity. I'll also add this method to an iteration named iStateMethods. That's most of what we need in our idling state. Right now we'll only add the transitions to other states, and later on in the series we'll finish whatever is left to do here. Taking a look at our movement system states, the idling state can transition to the following states: walking, running, dashing, and jumping. Because we'll only do dashing and jumping later on, we'll only transition to the walking and running states. The way we'll be doing this is by using something from the new input system, which are callbacks.
Every action should have 3 phases:
started, performed, and cancelled. When these are called depend on the action type that we chose when creating the input actions. In our case, we need the movement input, which is of type value. For the value action type, started means when we first press one of the keys. Performed means whenever we press a key after the first one without actually releasing it, like going from W to WD. And cancelled means releasing the input keys completely. We'll be using these actions for most of our transitions, but in some cases this leads us to a problem. Let's say we were idling and decided to jump. Whenever we are in the jump state, moving in the air is not possible. But we are still able to press the movement input keys if we don't disable them, which we won't. In that case, if we hold one of the movement keys while in the jumping state and then land, the expected outcome is for us to start moving. However, because the movement input has already started when we were jumping, the callback we'll add on the idling state won't be called anymore, which means we will stay in the idling state even though our movement keys are pressed. If we were to disable the input when we jump and then enable it when we land, then the started will be called again. But because we won't be doing that here, we need to find another solution. Thankfully, this is quite simple to solve. In our update method, we simply need to check if our movement input variable is not 0, and if it isn't, it means we should start moving. This works because our movement input is of value type, which continuously tracks changes. And if you remember, we are constantly reading for those changes in the player movement state update method. So let's do that by typing in override, update, and pressing enter. Here type in if movement input equals vector2.0. If that's the case, we can return. Otherwise, we'll call in a new method named onMove. Note that even though this is in our update method, it will only be called once, as we'll be transitioning states in this method, meaning our current state will change to another state on its first call. Now in Genshin Impact we can go from idling to walking or running. The transition depends on our walk toggle. If the walk is toggled, then we'll transition to the walking state, and if it isn't, we'll transition to the running state. Of course, we don't really have a way to know in what toggle state we are, so we'll start by creating a variable in our player movement state script. In here, create a new variable by typing in protected bool showed walk. To update it, we'll use the walk toggle input action started action.
For the button type, started is called whenever we press on the input key. Performed is called whenever the input action is performed, which can change if you add an interaction like hold. An hold interaction of 1 second here will only call the performed action when the button is held for that 1 second. This will be useful for us later on. For an input action without interactions though, this will be called right after the started action. Cancelled is called whenever we release the input key.
Start by going into our enter method and calling a new method named add input actions callbacks. In our exit method, we'll also call in another new method named remove input actions callbacks. Make both of these methods protected and virtual, and move them to the reusable methods region. The way we can add a callback to the input started action is by typing in statemachine.player.playeractions.walkToggle.started plus equals on walk toggle started. If we generate a method for this, it should also come with a parameter. We do not need to pass this parameter when we add this callback, as C# does that for us already. I'll rename it to context. I'll also make this method be protected and virtual and add it to a new region named input methods. What we'll do here is quite simple. Every time we press the walk toggle input key, we'll set the showed walk variable to its opposite value, which we can do by typing in showed walk equals to not showed walk. This is how you add a callback to an input action. Now, we aren't really using the context variable here, so do we really need to pass it in? The answer is actually yes. Whenever we add a callback, we need to make sure we also remove it. The reason why is because we are adding a callback every time we enter a state, which means that if we were to enter it 10 times, we would have 10 of the same callback being called. However, Unity needs to know what's the callback we are trying to remove, and apparently it needs this context variable to know it. I've tried in a project before removing the context parameter, and it didn't really remove the callback, so we need to make sure it is there. Now, to actually remove the callback, we simply copy our line that has it and paste it in the remove input actions callbacks method. Then we swap the plus operator with the minus operator to subtract or remove this callback. And that's our walk toggle callback done. So go back to our player idling state, and in here we can now use a showedWalk variable for our transitions. To do that, type in if showedWalk. We shall then transition to the walking state by typing in statemachine.changeState and pass in statemachine.walkingState. We can of course return from the method right after that. Otherwise, if we aren't supposed to be walking, we shall go to the running state. So type in statemachine.changeState and pass in statemachine.runningstate. We are now able to transition to another state from the idling state. Of course, we haven't yet done the other state's logic, so if we were to change states now, our player will stand still due to the speed modifier still being 0. Let's start by adding our logic to the walking state. To do that, open up the player walking state script. We'll start by overriding our enter method, and then set our speed modifier to be around 0.225f. This will make it so our player moves slowly, much like he was walking. I'll add our enter method to an iteration named iState methods. Note that every value that I'll write are values that I found to be somewhat close to Genshin Impact. And that's really it for our walking state logic. We simply needed to make it move slowly. Of course, we also need to add transitions to other states, so let's take a look at our movement system states. From the walking state, we can transition to running, light stopping, dashing, and jumping. Again, we'll add dashing and jumping later on in the series. For our light stopping, we'll also add it later, so we'll instead transition to the idling state for now. We'll use callbacks for these transitions. The first one is to the running state. This happens when we are walking and untoggle the showed walk variable. Thankfully, we can do that very easily by overriding the onWalkToggleStarted method. I'll add this method to an iteration named inputMethods. We need to call our base method logic here as it takes care of setting the showed walk variable for us, and all we need to do here is to transition to the running state by typing in statemachine.changeState statemachine.running_state. That's it for our running transition, so for the other we'll be adding a new callback. We'll be using the movement cancelled action for this. So start by overriding the add and remove input actions callbacks methods. I'll add them to an iteration named Reusable methods. Then call in statemachine.player.input.playerActions.movement.cancelled plus equals onMovementCancelled. I'll make this new method protected, rename the parameter to context, and add it to the input methods region. Make sure you also remove the callback we've just added in the remove method. In the callback, we'll simply type in statemachine.changeState statemachine.idlingState. That's all we need for our walking state. So let's next do the logic of our running state. So open up the player running state script. Start by overriding the enter method and set the speed modifier to be 1f. I'll add this method to an iteration named iState methods. Again, that's all the logic we need, so all that's left are the transitions to other states. Looking at our movement system states, our running state can transition to walking, medium stopping, dashing, and jumping. This is much like the situation of our walking state. So let's head back to the player walking state and copy the whole input methods region. Then back into the player running state, paste the code we've just copied. Our onMovementCancelled callback is as it should be for now. For our onWalkToggleStarted, we'll swap running state with walking state instead. And that's all we need to do in our running state. Go ahead and save all the files and then go back to Unity. Entering play mode, our player should now be working fine, and our debug.log should show the correct state. If we start running and toggle our walk by pressing the left control key, we shall start moving slowly. Of course, toggling it again shall now make the player go back to its running speed. However, we currently have two problems. The first one is that we are starting to unnecessarily repeat some code in our states, like our on-movement cancelled callback. We are also hard-coding our values, such as for our speed modifier. The second one is regarding our showed walk variable and how we are currently reusing data between states. Let's exit and enter play mode again to make sure everything is reset to its default values. Right now our showed walk variable should be set to false. That means that if we start moving we should enter the running state, which is what's happening. But let's now toggle our walking state. With this, not only are we moving slowly, our showed walk variable shall now be true. Let's now stop moving to enter the idling state. What do you think will happen if we start moving again? From what we've done so far, because the showed walk variable is now true, we shall start walking. However, we can see that's not the case and are instead running. The reason why that's happening is quite simple. The showed walk variable is not static, which means each state has its own showed walk variable. So, while in our running state the showed walk variable became true, it remained as false in our idling state, hence why we started running instead. We can further see this if we stop running, press left control, and start moving again. We shall now be walking. One way of possibly fixing this is by setting the showed walk variable to be a static variable, meaning it will be shared across all instances of the player movement state class. However, that isn't a great solution when we can have more than one player, like in co-op games, as it will make it so every player will share the showed walk variable with each other. What we'll end up doing instead is to create a class that holds data that can be reused between all of the states. Before we do that though, we'll start by fixing our first problem, which also involves removing the hard-coded values of our code. We don't really have a lot of code that can be reused in our moving states right now, but we can still update a few things. In our case, we'll be moving our onMove, onMovement cancelled and the input actions callbacks methods to a new state, which will be our grounded state. Of course, we still need to create a state, so go to the player states folder in the grounded folder. In here, create a new C# script, which I'll name player grounded state. Open it up and remove the default methods. We'll also swap the mono behavior inheritance with player movement state instead, and generate the constructor it needs. When we are done doing that, we'll go ahead and swap our moving and idling states to inherit from this state instead. So go to the player idling state and swap the inheritance. When that's done, do the same for our walking, running and sprinting states. Then go to the player walking state script and copy or cut the input actions callbacks methods. Next, paste that code into the player grounded state script. Then we'll go get the onMovement cancelled method from the player walking state script as well, and paste it here with its region. Make it a virtual method as well. When that's done, remove them from the player running state script. Next, we'll go to the player idling state script and copy or cut the onMove method and paste it in the reusable methods region of the grounded state script. We'll also make it a protected virtual method. That's all we need to reuse for now. All that's left is to create a way for us to set our current hard-coded values through the inspector and also create a reusable data class for us to reuse data between states. So go back to Unity and move back to the player scripts folder. In here we'll create another folder named data. Inside create two other folders, Scriptable Objects and States. Inside of the Scriptable Objects folder, create a new C# script. I'll name it Player SO. Inside of the States folder, create two new C# scripts, Player State Reusable Data and Player Rotation Data. Then create a new folder named Grounded. Inside of the Grounded folder, create a new C# script, Player Grounded Data. Then create yet another folder named Moving, and inside of that folder, two new C# scripts, Player Walk Data and Player Run Data. The Player SO or Player Scriptable Object will hold most of the values we'll be using throughout our system, such as the speed modifiers or rotation reach times. The Player State Reusable Data will hold the data that needs to be reused through multiple states, much like our Should Walk variable or our Movement Input variable. Start by going back to the Scriptable Objects folder and open up the Player SO script. Remove the default methods and swap the mono-behavior inheritance with Scriptable Object instead. Then create a new public property of type Player Grounded Data. Name it Grounded Data. I'll give it a private set. Because we'll need to set this in the inspector, add the field serialized field attribute to it. The field serialized field attribute should work in Unity 2020 or above, but if it doesn't work for you, use public variables instead. I believe you can also use it with non-automatic properties as well. That's all the data we need here, so now we need a way to create this scriptable object. We can do that by adding, just above the class name, Create Asset Menu. I'll pass in the file name of Player and the menu name of Custom Characters Player. When that's done, open up the Player Grounded Data script. In here, remove the default methods and inheritance. We'll hold the base speed of the player here, so type in public float base speed and give it a private set and a default value of 5f. Then give it the field serialized field attribute together with the field range attribute from 0f to 25f. Then we'll add our rotation data by typing in field serialized field public player rotation data base rotation data with a private set. Next, we'll add our walk data and run data, so type in field serialized field public player walk data with a private set. And duplicate this line, swapping the walk with run instead. To make this class show up in the inspector, we need to make it serializable by typing in just above the class name serializable, which requires the system namespace. We'll now set our player walk data, so open it up and remove the default methods and inheritance. Then type in field serialized field range from 0f to 1/2 public float speed modifier with a private set and a default value of 0.225f. Make this class serializable as well. That's all for our walk data, and our run data will be the same, so copy the speed modifier variable and open up the run data script. In here, remove the default methods and inheritance and then paste the variable line and swap the range to be from 1f to 2f and default the value to be 1f. Don't forget to make this class serializable as well. All that's left for our SO data is the rotation data, so open up the player rotation data script. Start by removing the default methods and inheritance. When that's done, add a new public vector tree named target rotation reach time, giving it the field serialized field attribute. Make this class serializable as well. That's it for our scriptable object data. So for our reusable data, open up the player state reusable data script. In here, remove the default methods and the mono behavior inheritance. I'll be showing on the screen the necessary data to be reused. Let's start with our movement input by typing in public vector2 movement input with a public set. We'll be giving a public set to all of the properties here, as we need to be able to set their values. Then add a speed modifier by typing in public float movement speed modifier and default it to 1f. For our should walk, type in public bool should walk. With that done, we now need a property for all of our vector trees. However, we have a problem when doing that. Whenever we have a vector tree property, we cannot set its variable from another class. So creating a vector tree here wouldn't allow us to change its x, y and z variables from our states. This only happens when it is a property, because properties return a copy of the private variable they create when its type is of value type, which means changing its x, y or z wouldn't do anything in the original vector tree. We could fix this by making it a public variable instead of a property, but we'll actually fix it by making it so that the property returns a reference of our private variable. This means that we can change its variables as it's not a copy anymore, but a reference to the actual vector tree. To do that, first create the private variable by typing in private vector tree current target rotation. Then under it type in public ref vector tree current target rotation. We'll have to set the get ourselves and return a reference of our current target rotation. We don't nor can give it a set because it is by reference, which basically means do what you want with it already. Now, the reason why we also need the ref in our property and not just in the return is because properties are methods. So our ref vector tree is basically our property or method return type, which requires the ref keyword if we are returning a value by reference. All that's left to do is to do the same for the other three variables. So duplicate the existing one 3 more times and change the variables and properties name to time to reach target rotation, dumped target rotation current velocity, and dumped target rotation past time. Make sure you make all the properties public. We now have our reusable data. Of course, we do still need to create our player scriptable object in Unity and also swap the current data usage with our data classes. For our player scriptable object, head back to Unity and go to the Assets folder. In here, create 3 folders, each inside of the other: Scriptable Objects, Characters, and Player. Then we'll create the Scriptable Objects by going to Create, Custom, Characters, Player.
I'll name it Player.
You can also access this menu through the Assets top menu. We already have most of our default values set to the correct values, but because our base rotation reach time is a vector 3, we weren't able to set a default value. So, change the Y value to be 0.14. That's all we need, but I'll also add a new Inspector tab by right-clicking in Inspector tab and going Add tab, Inspector. Then I'll lock this tab so that if we ever need to access a scriptable object, we can come here without needing to go through all of the folders. When that's done, go back to the Other Inspector tab. Our scriptable object is now created, so we need a reference to it in our player. To do that, open up the player script. In here, create a new public property of type player.so, to which I'll name data. Add the field serialized field attribute to it as well. I'll also add a field header for references. When that's done, go to Unity, select the player game object, and add the player.so to the respective field. That's it for our scriptable object. We now need to add our reusable data, and we'll do that in our state machine. We could add it for every single state, but it's unnecessary. So open up the player movement state machine script. In here, type in public player state reusable data. I'll omit the set. Then in the constructor, type in reusable data equals to new player state reusable data. We can now start swapping our values with our data variables. Start by opening up the player movement state script. We'll be using the rename function of Visual Studio for this, which other IDEs should also have. However, it doesn't really let us add a dot ourselves, but we can cheat that by typing in state machine dot reusable data dot select it and then copy or cut it. Then we'll go to our variables and we'll select the movement input variable and right click on it and press rename, or just use the F2 shortcut. When that's done, put the cursor on the beginning of the variable name and paste our state machine reusable data text. Of course, change the M to be uppercase as well and press enter. This renamed our movement input variable usages to what we needed, so feel free to delete the variable now. When that's done, do the exact same thing for the other existing variables except the base speed. Rename the speed modifier to movement speed modifier as well. Once we are doing that, we need to swap our hard-coded values with our SO data. For our base speed, we'll remove the current variable and create a new protected variable of type player-grounded data named movement data. Then in the constructor, we'll set the movement data to be equal to the state machine .player.data.grounded data. When that's done, go to the getMovementSpeed method and swap the old base speed with movementData.baseSpeed. Now in our initializeData method, we'll swap the hard-coded 0.14f with movementData. base rotation data target rotation reach time. We'll also remove the .y from the time to reach target rotation. All that's left now is to do the same thing for our hard-coded speed modifier values. So go to the walking state, and swap the value with movement data.walk data.speed modifier. And then go to the running state and swap the value with movement data.run data.speed modifier. We don't need to set our idling state modifier because it is always 0. We don't need to make the movement data reusable either because it's always referencing to the same scriptable object data. We are now reusing our data and not hard-coding any values besides the speed modifiers of 0. If we go into Unity and enter play mode, you might have noticed when going against a wall that we kinda get stuck in there. We'll be fixing that by giving our player a physics material with no friction so that we don't get stuck anymore. So exit play mode and in our materials folder, create another folder named physics. Inside, create a new physics material. I'll name it player physics. Then set every field to be 0. And as done, drag it into our capsule collider material field. If we enter play mode again, going against a wall shall no longer get us stuck. As a last thing, while we won't really be reusing any data or logic with it, we'll create our player moving state. This is because we'll need it when animating, so we might as well just create it now. So go to the player ground state scripts folder, and in the moving folder, create a new C# script named player moving state. Open it up and remove the default methods and swap the inheritance with player ground state. Then go to the walking, running and sprinting states and swap their inheritance to inherit from player moving state. That's all we'll need for now. Saving it all and going back to Unity, entering play mode shall now have our showed walk variable working fine. If we start running and press left Ctrl, our walking will be toggled and will start moving slowly. If we now stop and then start moving again, we shall start walking instead of running, which means that our variables are indeed being reused between the different states.